So you are now focused on mood. And I wonder if we can start with a definition of how you think about what mood is and why do you think it is compelling enough to make it your new direction of your studies.
So, mood is often differentiated from emotion, and I think it's an important difference. So, our emotions are typically thought of as being triggered by something. So, if I see a tiger, I will become afraid. Our moods tend to be more diffuse and slowly changing. And so then the question is, well, why is that? One of the things that we know about moods is that they are an integration over many experiences. They're not just triggered by one. Okay. So a lot of our behavioral research suggests that there's something like a running average of the goodness and badness of things that have happened to you lately. So big questions in mood research are things like, well, how is the brain doing that averaging over recent events? Another big question in mood is it's the ultimate kind of loopy system in terms of these feedback loops that I've been talking about. And that's one of the reasons I selected it to study it. So we know that our moods are this average of the things that have happened to us. But we also know that our percepts of how good and bad things are depends on our moods. So if something happens to you and you're in a good mood, you will perceive it as better than it actually is. And if you're in a bad mood, you'll perceive it as worse.
Okay.
So now we have this big loopy system where our moods are the average of our percepts of how good things are that have happened to us, but our percepts in turn impact our moods. So there are big questions about how is it that we don't just have 5 bad things in a row happen to us and we spiral down into a depression? Or how is it that 5 good things happen to us and we don't spiral up into mania? So we have all these mechanisms that presumably reside in our brain in order to keep mood within a normal range. And one of the questions is, when someone is getting out of that normal range, what about those mechanisms are going awry? So those are kind of some of the classic questions that we're after in mood neuroscience. Okay. Another question that we're after is the question of what bits of the brain are actually taking in your experience and then transforming them into mood. And we're really interested in creating big models of how that works so we can hand those models off to our clinicians who do things like stimulate the brain non-invasively. You can stimulate the brain with magnets and that's one treatment for depression, actually. You can target TMS, it's called, transcranial magnetic stimulation, but it doesn't work for everyone. And so maybe for some individuals, that's the wrong treatment, it's the wrong brain area. So we want to give them big maps of how the brain, the mood network, and what each bit of it is doing, so they can then transform these maps into clinical treatments.
As you now look to switch your research, is there a fundamental question or two that you feel like you really have to answer about mood in order to understand it even to a greater degree?
Yeah, so for me, the one that we're really trying to, I've kind of hinted at some of the questions we're trying to approach out of the gate. But the way we approach mood is it turns out that a really terrific mood induction paradigm is to have individuals play gambling games. Okay. So when you play a gambling game, when you win, it makes you happier. And when you lose, you become less happy. Okay. And what's really nice about these is we can have individuals play many trials of this, and we can ask them every few trials, how happy are you right now? How happy are you right now? And then we can see what their mood depends on in the gambling game. And so the sorts of things that we learn are individuals, their happiness doesn't just depend on what happened on the last trial. They are, in fact, their happiness depends on many trials and kind of this running average I was talking about. And there are some more subtle things that we can extract as principles. For example, if you get to choose in these gambling games where you want to win some money for certain, or you want to take a gamble, and if you win because you took a gamble, it makes you happier than if you win if you took the money for certain. So we really like surprising things.
Yep.
Like winning makes us happy, but surprising winning makes us even happier. And then once we have these, they're actually models that we can use to predict how anyone's happiness will fluctuate as they play these games, we can then go into the brain and we can ask, where in the brain is processing the events you won or lost? and where in the brain is converting that experience of winning and losing into this running average called mood. So we're trying to create these big loopy dynamical systems maps that I was talking about that we can then hand to our clinical colleagues who are trying to design new therapies for transcranial magnetic stimulation and on, in order to create clinical therapeutics.
Okay.
That's one way that we're really, that's one class of questions we're really interested in. But I also want to emphasize that part of this research that I do, it's really just trying to understand the nuts and bolts, and we have no idea where it will lead. So looking into the brain and trying to understand how the brain does this, like how the brain stops, we were talking about this loopy loop, how does the brain stop the system from spiraling out of control, either into depression or up to mania? Those principles might give us insights in how to create new behavioral therapies that have nothing to do with the brain at all. So there are a whole suite of very of therapies that are quite effective for some individuals at treating depression and anxiety, but they don't work for everyone, right? And so everyone is always on the hunt for kind of new ideas about how these systems work that we can then use to design new therapies.
Okay.